So today's, it's the end of the package. It's about the last 5 to 10 questions, and really they would fall under a category you call statistics, some of which you've probably been exposed to before. I mean, I found in the past when last year when I was doing Algebra 1, that actually most had already done stem and leaf and box and whisker. How many remember doing that stuff? Okay, so that's what it's about. We're going to review how that works and look at the questions in there and how you would have answered them. And how many of you remember doing mean, median, and mode? Okay, well, mean, median, and mode are part of this a little bit, but then we'll move a little bit beyond that. So here we go. Let me change my pen to blue. Okay. So remember what a stem and leaf is. Usually you get the stem and leaf, and it's like a shorthand way. This is number, did I not? Oh, because at this point we're not actually going to the question. This is a shorthand way to write a bunch of data. So the stem, in this case, the stem is like the tens place, right? And the leaf, whatever this is the ones place. So 4 in this column with a 2 in this column would be the number 42. So you remember that? So you could unpack that, and it would tell you that those numbers there actually represent 40, 40, that's the 2 zeros, 41, 43, 44, 45, 46. Okay, then we jump to the 50s, 50, 52, 52, 53, 53, etc. So you just unpack it that way. How do you calculate the mean of a bunch of data like that? Yeah. Okay, so let's do that. Let's add them all up, divide by how many are there? Let's see, I can just add these up. 1, 2, 3, 4, 5, 6, 6. That is 14, 6 is 20. So add them all up. You got a calculator? Add them up, divide by 20. When you get to these kinds of problems, a lot of it, you're going to use the calculator in the end, right? So you got to make sure you're at least using the calculator correctly and getting the same thing as everybody else. I mean, if you enter a wrong number, you're not going to get the right thing. Yeah. 51.6. Let some others finish and back you up. Who else says 51.6? 51.6? Keith? Yeah, there's 20 of them. Everybody's getting into 51.6. So I'm going to write that down, 51.6. Okay? How do you tell the mode? The one value that's there the most, right? So let's see. I know that there was some 2s in there. Was there anything that... oh, yeah, look, at 56 was there once at the end of that. Well, right there. 6, 6, 6. So whichever one occurs, that was inadvertent. Oh, I'm sorry. Okay, so the mode is 56. The mode is 56. Okay. How do you do the median?
You have to cross out all the numbers until you get to the middle.
Yeah, I mean, usually if the data is not in order, you put it in order first. Well, this is in order. So once it's in order, you throw out the high and the low and the high and the low until you just got like one number in the middle. It's the middle value, not the average. Yeah. You take the average of those two. You add them up, divide by 2. So I mean, we could do it on this list right here, right? 40, 64, 40, 63, 41, there. Okay, now I'm at least on the same line. 46, 56, 50, 54, 52, 53, and now there's actually 2 values in the middle, so the median is, add it up, divide by 2, 52.5. Okay? Because that's what you get if you add them up and divide by 20. Okay. Now, in a way, we are going to keep doing that, but truthfully, the calculator allows you to do that in a way which is better, that it's a better place. And we've used this before when we did scatter plots. Remember doing scatter plots?
Yeah.
That was really in the first semester, but With scatter plots, we went to stat edit, and we put all the x values under L1 and the y values under L2. Well, now we only have one list of data. So still, go to the stat button, edit, and put all those numbers under L1. Okay. So let me curve that over. Okay, calculator time. So go stat, edit, and in that column of data, which it looks like I've already put in there, it's probably the last thing I did, and you enter all your values. Now notice on the bottom, it shows you like what line you're on all the time. So it's saying L1 in parentheses 7, that means it's the 7th one in the list. Because when you're adding a big string of numbers, you know, sometimes it just helps at the end to make sure you've added as many numbers as you were given. So I can tell at the bottom of the list, I'm in the 21st spot in the blank after the list. So yeah, the last number was 20. I got all 20 of them in there. Okay, so once you've done that with the calculator, right, you enter the data, stat, edit, then you do stat, calc, 1, enter, right? Stat, arrow over to where it says calc on the top of the screen, and then number 1 variable statistics, and you hit 1, and you're going to have to hit enter 3 times. 1, 2, 3. So you can see that you get some numbers here. Now, this first one, the X with a bar on the top of it, that's the mean. That is one way you can describe the mean. The calculator uses that. So the mean is X bar. That's how you pronounce it. And it's 51.6, which is what everybody said, so we're good on that. Okay, now, if you scroll down that list, right, if you scroll down, actually there's some more information. And one of the things you can see there is the median is there, 52.5. So it actually will do the median for you too, without you having to like put it in order, throw out the high and the low. Yeah. Eventually. That's the data we're using, but we haven't really got to 44 yet. So you need to know how to put this in the calculator to calculate these things, right? You don't want to be doing some of this stuff by hand, believe me. Now, this data is actually coming from, I think Edric just pointed it out. I'm not sure if it's my next slide. Yeah, it's number 44. And 44 is not actually asking us for mean, median, mode, or anything like that. It's asking us for some things that supposedly we would know how to find that are on the formula sheet that we got for Algebra 1. And here's the 3 formulas that are somewhat related, right? Variance, standard deviation, and mean absolute deviation. I have a little bit of a problem with this because none of those, all those formulas have this notation in there that nobody knows what that means. And so there's no way you're going to sit down and by hand calculate these. But if you go back to the calculator, right, I think I put it on the next screen. If you go back to the calculator on the top part of the screen there, right, where we had the 51.6, the standard deviation is actually that one, and it's right above where it says n equals 20, sigma x, that's the standard deviation. So we're not using that formula. I guarantee that, you know, most of the kids in math analysis would get it wrong if they had to sit down and by hand do standard deviation. I mean, we've seen it all too many times. But the calculator does it for us, so it's not really that big of a deal, right? So we just put it in, stat calc 1, and that's what you're looking for, standard deviation. Now, if you look in the 4 options here, the standard deviation is clearly, there's only one that has that 7.61. And so we don't really have to address what's in this column right here, which is called variance. But if I go back to those formulas, what you notice is, here's the standard deviation, which we use that little Greek letter sigma to represent standard deviation. The variance is just the square of that, right? So actually they're related. One is the square of the other. So if I look at this number here, 7.61, see what you got if you square it in the calculator. 7.61 squared is? Anybody? How long does that take? Not the square root of, squared. 7.61 squared, right there. And you should be getting something around 57.94. So, I mean, those two, if you had to the calculator doesn't give us the variance, but we know it's just the square of the standard deviation. They weren't too tricky about it in the problem. I mean, if you look here, 4.15 and 7.2, okay, they're squared, right? And this one is definitely just squared. This one is not. So they gave a standard deviation there that if you squared it, you would have not gotten that, because that's our variance. But the main thing to remember is standard deviation is stat calc 1, and it's this little symbol followed by an X. Yeah.
So, how did you get it? You insert it in the calculator, right?
Yeah.
Like, would you go to y equals or just stay?
Stat, no, you'll go to y equals. So stat, edit. Okay. So standard deviation, quiet please. Standard deviation is not a measure of the center, right? Like mean, median, and mode, they're trying to tell you the center of a bunch of data. The standard deviation is trying to tell you how spread out is the data. All right, it's, we call that a measure of spread. I think the book uses the word dispersion for that. I know that you've done range before. Like what is the range? When you have the highest minus the low. Well, that's a measure of spread. Like the bigger it is, the more spread out your data is. That's what standard deviation is. It's just another way to measure the spread. It's like the most used measure of spread when you get into real statistics. Range, not so much. So let's go. This is number 43 in your package. Right, it says, a survey was taken on the number of pets students owned, and the data was recorded and displayed in a histogram. Right, this is a histogram. The mean amount of pets was 11.1. Wow, that is a lot of pets. And the standard deviation of the data is 4.4. So you look at each one of these rectangles, it's got a scale on the bottom, right? So this one here includes 0 to 4 pets. This is 5 to 9 pets, 10 to 14, and 15 to 19 pets. So where would we find? That means for everyone who said that they had 15, 16, 17, 18, or 19 pets, that made that rectangle bigger.
That is a lie.
Yeah, that is what they're saying.
At least
maybe that's in the country, maybe they got farms, lots of cows, things like that.
Hey, like kale. Kale has chicken. Yeah.
Okay, quiet please. Okay, guys.
Oh, sorry.
Okay, so we got to finish the problem, right? It says, which intervals may have data points within 0.5 standard deviations of the mean? Okay, if the standard deviation is 4.4, right, what is 0.5 times 4.4?
I don't know.
Yeah. It's 2.2. So when it says which intervals would have data points within 0.5 standard deviations of the mean, they're saying what is the mean 11.1 plus 2.2? 13.3. Right? What is 11.1 minus 2.2? Okay, Ty, here you go. No calculator.
This is 8.9.
8.9. There you go. Okay?
I am so surprised.
So the question they're asking is, which one of these intervals would be included if we went from 8.9 to 13.3? Is 8.9 to 13.3 and 0 to 4? How about 5 to 9? Yeah, the 8.9 gets a little bit into there. Okay, and then obviously it's going to be in here. That's where the mean is. And then does it go up as high as 15 to 19?
No.
So I think this was probably one of those technology enhanced. You just click this one and this one. I mean, for sure you would click on the mean, right? Which is 11.4 would be here, 11.1, and then you would have to calculate to see which others.
You want to bet?
Okay, let's go.
Look. Right there.
So quiet, please. So two other measures of spread, how much things are spread out, are called interquartile range and the mean absolute deviation, which was the third funny formula on the sheet, which we will not end up doing. But we can figure it out easily enough. This is the question number 42. It's 42 in your package, right? Calculator doesn't do this one for us other than, you know, you'll be able to do some of the arithmetic in the calculator.
That's a lot of people.
So in this case, it says the Centers for Disease Control and Prevention conducted a survey on adults suffering from asthma in different parts of the United States. The data is shown in this table. Okay, what is the mean absolute deviation? Okay, to calculate the mean absolute deviation, you got to know the mean. So what's the mean of all these numbers?
Adding the whole. I can't use my head. Yeah, you do. Yeah. Oh, try.
Right? Somebody tell me the mean.
5,736 points. Yeah, I did that one. 189,000. I got 5,736.25. I'm smacking them cheeks. Whoa. I got a large. Yeah, it's mean.
Oh. Okay, so the mean is, guys, Ty, right? You're out of control today, you know that? 57, 376.25. Okay, so once you know what the mean is, then we need to subtract every one of these numbers minus the mean. Remember that we're going to call the mean X bar. So we're going to do this 4 times. What is 40,577 minus 57? Yeah, we need 4 numbers there. So we're going to get negative 16,799. Right, just we're subtracting every number there minus the mean, which we said is the 57,000. So I'll try the next one. 53,316 minus 57 376.25. Okay, what'd you do? Well, you need to do it again because it's wrong. 45, 77, 53, 76, 81, and 53. Not by 20. There's only 4 numbers there. Don't divide by 20. Divide by 4. Okay, what's the second one? What's the second one?
Negative 4,060.25.
Ty, say again.
Negative 4,060.25.
Okay. We're not done yet. Negative 4,065. Ty.
No, it's 60. 60.25.
60.25. Okay, what's the next one? Look, you're going to get a question like this on the test tomorrow, and you could be writing notes on how to do it right now. Okay, what about the third one? 81,000 minus 57,000. 75? How about the last one? $3,485.25. Okay. So now, the absolute part of this, you know, it says mean, absolute, deviation, absolute value. Right? What does absolute value do to a negative number? It makes it positive. So we just want to turn all these into positive numbers and take their average. Right? So turn all these positive, take the average of them. That's the mean absolute deviation. Right? So the part of this which is the absolute means we're only interested in positive differences from the mean. So add all those up and divide by 4. Yeah, just eliminate the negatives and add them up like they're all positive numbers. Yes, that's what it's telling you to do ultimately. So what are you going to get when you add those up and divide by 4? 12,172.375. So you get the B.
Yeah.
You get the B. Now, if you would have used the calculator to calculate the mean, let's say, right? You would have found right away that the mean was answer D. Well, that wasn't going to be right. The mean is not the same thing as the mean absolute deviation. And if you would have found that actually the C, that was the standard deviation, so that's not it. It would actually, what would have come down to just these two. So, I mean, you could have process of elimination, you would have been stuck with the 2. But that's how you do it. Calculate the mean, subtract, turn them all positive, and take their average. That's mean absolute deviation. Subtract those the numbers in the table minus the mean. Right? Remember the X bar is the mean. Okay, next. Okay. Now, these are kind of like histograms. You know, where you make an X above the value on the X-axis, so you can kind of see where they get that from. Now, in the question here, they say the height of each student in 5 4th grade classrooms, they were recorded on, they're called a line plot. The data below shows the height of each student in classroom 1. The data from the other classrooms all had the same mean height, but different standard deviations. So here's the result for classroom 1. The mean is 52.01, standard deviation is 4.91, and mean absolute deviation 2.97. They want to know which one of these 4 would have a standard deviation of 3.67. Well, look at the standard deviation of classroom 1 was 4.91, So 3.67 is less than that. So what they're actually asking you is which one of these here looks like it's less spread out. You don't have to calculate anything. Just look at how much this data is spread out, and then look at these 4 here and see which one looks like it's less spread out than B. There's your answer, right? I mean, you could like go in and like turn every one of those X's into a value and try to calculate, but even that would not come out exactly the same. I mean, you could see that when they measured their heights, you know, this says 44, 46 is like nobody's ever got an odd number of inches height. So I think they're actually more like the bins of a histogram. So I mean, if you calculate, it might be a little confusing, but it ought to be fairly obvious that, for example, this one looks like it's more spread out. This one, these two look like they're more spread out, but this one is definitely more compact. It's the only one. So I'm just looking at that, comparing 4.91 and 3.67. That's telling me, look for the one that's less spread out. B. Yeah. Yeah, you don't have to calculate. It's more just understanding that these things are measures of spread. How spread out is the data when you look at it? Okay, z-scores. This is a formula on the formula sheet, which you will have, right? There's 4 letters in there, kind of letters, right? There's Z, and then there's X, and it tells you, this is from the formula sheet. X just represents one value of data. This funny looking U there, that's another way to say mean. So right there, it's the data value minus the mean in the numerator, and then that little sigma we saw that was standard deviation. So the kind of questions you get related to this is using this formula, which you're given, they'll give you 3 out of the 4 values you calculate the 4. Right? That's all you're doing with it. So for example, in the next one, this is 45 in your package, yeah. What is what? This whole equation that's there? It's just a way to calculate this thing called z-score. Well, literally, the z-score is telling you how many standard deviations away from the mean something is. So, for example, let's say the mean weight lift for football players, and let's say it's a bench press, was 325. They're not high schoolers, okay? If somebody lifts 375, and let's say the mean was 325 and the standard deviation was 25, then if somebody lifts 375, you'd say, well, that's 50 more than the mean, and 50 divided by 25 is 2 standard deviations above the mean. It's a way that you use, you try to like put things on the same scale. Like if I'm trying to compare one player who's like a lineman and strength is really important, and then I'm comparing him to a running back where speed is really important, then you know it's hard to compare like directly the numbers, like the sprint time to the weight lift. But if I reduce it all to z-scores, then actually I can compare. Maybe the runner is just like a little 1 standard deviation better than the mean, but the lineman is on the weight lift 2 standard deviations above. So that's how you try to, it gives you like a common reference point when you're comparing different kinds of things. But we really don't do much with it other than to just like, here's the formula, here's 3 out of the 4, calculate the 4th. So look at number 45. Given a data set with a mean of 5, a standard deviation of 3, and a z-score of 1.8, then find what is the value of the element associated. So they're giving us the values of this symbol, which actually you call mu, right? Mu, and standard deviation, and z. So if we plug in these 3, can we solve for x? So let's see what that looks like. All right, this is going to be the z-score was 1.8. The x is what we don't know. The mean is 5. And the standard deviation is 3. Now, if it's hard to solve it, another thing you can do, and is just you could just like plug in, right? Plug in 5.4 here. 5.4 minus 5 divided by 3. Does that equal 1.8? No, it doesn't. But you could just like go through the list until you find the one that works, right? But if you were going to solve it, what would be the first step in solving that equation? I'm trying to isolate the x, and there's two things with it. Multiply times 3, right? So multiply times 3. Right, when I multiply times 3, then the 3's cancel. And now I've got 5.4 equals x minus 5. Okay, not quite done solving. What do I have to do to solve it? Add 5. Add 5. You could, but this is how you would solve it. So 5.4 plus 5 is 10.4. So x, the data value is 10.4. So I could say there'll be a question, and you got the formula on the formula sheet. You just need to fill in for 3 out of the 4, solve for the 4th, and if you can't, you could just back substitute the 4 answers until you find it. Yeah. Take it there. Okay. Box and whiskers. Box and whiskers. So a box and whisker is another way to display data. Like we saw the line plot before, we saw stem and leaf, we saw a histogram. This is another way. You know, it's the box is there. Obviously, you see that? The whiskers are the ends right there. And there's got to be some kind of scale so you can like read the values off. But these are all the parts of it, okay? And I've written them in a list there, and now I'm going to show you where those are. Most of you have probably seen this before, but the middle bar in the box is the median. Right? The most important thing, that middle bar in the box is the median. Okay? The left side of the whisker, that's the minimum value. So like I could go down from that dot onto the scale and I'd say, oh, it looks like the minimum value is like 39 or so. Right? The right whisker is the maximum value. Right? So I could say the maximum value looks like 85. Okay. So now, what does the median represent in data, in a set of data? Remember what it was? Because we just did it. It's the middle value, right? So the middle value is there. That means that there's 50% of the data to the left, and there's 50% of the data to the right. Okay? Now, if you just look at the lower, quiet please, right? If you just look at the lower 50% of the data, and you find the median of that, then that's the left side of the box. The left side of the box is the median of the lower 50%. So how much of the data would be to the left of that box? 25%, right? And then how much would be between the left side of the box and the median? 25%. Now you do the same thing for the right. Find the median of the upper 50%, and that's the right side of the box, right? So in fact, it's dividing all the data into chunks of 25%. 25%, 25%, 25%, 25%. Okay. Now, the left side of the box is called Q1, first quartile, or Q1. The right side of the box is Q3, or third quartile. And if you would subtract the value of Q3 minus the value of Q1, which is telling you the width of the box, that's the interquartile range. It's another measure of spread. So again, looking at a box and whisker, you can tell the range, right? The range is the max minus the min, and those are the whiskers. So that's not hard to find. But you know, a lot of times in statistics, you don't really want the range so much, Because you could have like a whole bunch of values in the middle and then one extreme value that makes the range look like it's, you know, but if you instead you look at how wide is the middle 50% of the data, that can't be affected by just like one bad value. So usually in statistics we don't really use the range, but we would use this box, IQR, interquartile range. So mostly what we do in these, the kind of questions you get here, you have to be able to look at something and just determine which one of these is true. Right? So here's a box and whisker plot for city A and city B, right? Temperatures. And there's the scale, 30 to 90, it's marked. So it says city A had a higher monthly temperature at the 75th percentile. Now where's the 75th percentile? It's the right side of the box, right? Because 75% of the data is to the left. City A had a higher monthly temperature, okay, it'd be right there, at the 75th percentile than City B had at the 50th, okay? So let's see, there's, at the 50th, it looks like City B was about there and City A is at the 75th. That's not quite true. That's right. City B had a lower monthly temperature at the 75th percentile, okay, right there, than City A had at the 50th percentile. This is lower than this? No. City B had the same monthly temperature at the 25th percentile, okay, that would be there, as City A had at the 50th. Yes, they're all lined up. The median, which divides this into 50-50, is the same as, okay. So the correct answer would be this one right here. Okay, let's look at another one. So this is a box and whisker for 4 different subjects. Looks like quizzes. And we have to say if the passing score is 70 for these quizzes, then A, the student failed more quizzes in math than in history. Let's see. History, the median was 65, but in math the median was 75, so that's a no. How about the student passed the most quizzes in English? Does it look like that? Yeah, I mean this box and whisker is completely to the right of the others, so there's your answer. That's all you have to do. Okay, remember how to do a scatter plot. Scatter plot.
Yes, I remember.
Stat edit. Stat edit. Right, you should put this in your calculator. What's that? We didn't do that one yet. No. We'll spend a little bit of time before we take the test tomorrow. Okay? We'll pick up with this again tomorrow, but the way to do this, stat edit, you put in all the X values under L1, all the Y values under L2, and then you go stat, calc, 4, enter, 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 I think it's 5 times. And then you see which one of these equations is right. Okay. We're going to jump ahead to homework. You can if you promise to bring it back. I'm not giving you another. If you don't bring it, you're taking a test without it. Okay? Yeah.
Is there going to be homework for tomorrow?
No.
Tomorrow.
Is there going to be any homework for the rest of the week?
No.